Okay, Assalamualaikum warahmatullahi wabarakatuh. So today is the first chapter of the introduction to the microfabrication. So let's see what we're going to study for this chapter. So this is about the first we go through on the MEM substrate. So there is the silicon wafers, and then the most important part is the photolithography. Okay, what is actually microfabrication? So since the name is micro, so we're going to fabricate the silicon wafer to become a device of a MEMS device. So usually the MEMS and IC are generally made from silicon wafers. Okay, so in order to do MEMS fabrication, we need to go to what we call clean room. So the traditional manufacturing is done by the big machine here without the clean room. But in order for you to make a MEMS device, you need to make sure you fabricate this in the clean room. So what is actually clean room? Because your device is very small, up to the micrometer, so it exposed to dust that is much more bigger than your device, the airborne or vaporized particles. So it is very important to ensure that your fabrication of the device is very clean. So will the device work if it is exposed to the normal conditions? So if we go to the SEM image of one of the device, so this is one of the micro MEMS device where it is up to the 10 micrometer. So we go zoom into the 10 micrometer, you will see 3 dust or organic vaporized particle on top of the device. So the device will not work when there is a dust or airborne. So in order to avoid that, so cleanliness is very crucial. So all your MEMS device need to be fabricated in the clean room. So let's say we are doing photolithography. So this is what we call transfer the pattern. So in order to do that, you really need to do it in a clean room, or we call this one a yellow room, to avoid the unintended patterns to be transferred to the wafer. Okay. So there are difference between clean room class 1000, class 100 or class 10. So the best clean room is class 1000, which means 1000 particles will exist. Not the best, the most sophisticated clean room is class 10, which is only 10 particles within a cubic foot. So if 1000 is more than 1000 particles, if 100 is 100 particles. So the highest class of the clean room is class 10. So usually in the university they will have like around class 1000 or class 100. Okay. So let's see what are the steps of the microfabrication. Okay, the first one is what we call layering. So layering means we add another one material on top of your device. This is what we call deposition. Another one is oxidation, means you are going to add oxide layer or SiO2. So in order to pattern this either metal deposition or the oxide deposition, so you need what we call patterning. So in this patterning is the most crucial steps on your MEMS fabrication. That is what we call lithography. So you're going to use the light to transfer the pattern, and it will be your deposition layer will be patterned. So either we etch or we add it. Okay. And the other part that is important if you are integrated with the IC is what we call doping. So if you know that inside your MOSFET you have P-type and N-type, right? So your P-type you dope with boron, N-type you dope with phosphorus or arsenic. So doping is important, where you're going to do ion implantation or diffusion. Okay, let's move to the flow chart of the microfabrication process. Okay, the most critical one is what we call patterning. That is what we call lithography. You are going to transfer the pattern by light. So in order for you to change to dope it, so we use the property modification. Either you are going to dope to become P-type or N-type. So this is what we call ion implant or diffusion. Okay, the common one is the subtractive process. Subtract means you remove something. So when you remove, we call inside here, we call etching. Etch. So there are two types of the subtractive process. The first one we call wet etching and dry etching. On top of that, we have additive process, where we call the physical vapor deposition, that is PVD. So this is biophysical. And another one, you're going to use the chemical solution where we call chemical vapor deposition, we call CVD. So on top of that, there are the third type, that is what we call oxidation. So this is to deposit the oxide layer, and the PVD usually for metal or piezoelectric layer, and also on top we have CVD. And the last one, after your device has been completed, you're going to move to the packaging. Okay, so let's see the process. First, you need to have a substrate. So your substrate can be silicon or other types. So if you want to integrate with the IC, your substrate is a silicon. And then you are going to have additive process where you're going to add one layer on top of your silicon. And how you're going to pattern that layer, you need to go through what we call lithography, where you're going to use the light to transfer the pattern. And at this area where the pattern has been transferred, there will be removal process, that what we call etching, to produce the pattern, and this process will continue repeatedly. So first, let's start with the MEMS substrate. So how we're going to choose which substrate that suitable for the device, so it depends on the application. Okay, the first one, if you are going to integrate with the IC, so you need to use silicon as the substrate. And the orientation is important. So previously we have learned about the Miller indice at the 001, 100. So this is the crystal orientation of the silicon. So the correct chosen orientation is important, depends on the application. And the last one is the size. So the bigger the size, the higher the cost. Okay, so why they use silicon substrate? First is the integration with electronics, and which one that we're going to use is depend on the application. Okay, and other than silicon substrate, some device use glass substrate. So why they use glass substrate? Because it is easily bonded with the silicon substrate, and for the optical application. So usually for they want transparent device, they opt for the glass substrate. Okay, the last one is the ceramic. So this is more focused on the high temperature applications and high strength and thermal conductivity. And quartz is also one of the important substrate for the MEMS device. So usually this one is for piezoelectric application, because quartz is one of the piezoelectrics. Okay, so it has a low coefficient of the thermal expansion. So this is more on the piezoelectric application. And the last one is for high temperature and the high voltage. Instead of the silicon substrate, we use what we call silicon carbide, because it able to hold high temperature and high voltage. Okay, since silicon wafer is the most chosen substrate for MEMS device, let's see how the silicon wafers are produced. So it's actually a crystal. So this is a silicon ingot, we call it. We cut it into dice, so it becomes like a wafer. So this is what we call wafer slicing and to polishing. So the process of the silicon wafer is what we call Zolkowski process. So this is the name of the guy. So it starts with the melt the silicon, and then they introduce the seed crystal, and then from that seed crystal it start to grow the silicon, and it pull the silicon up, and then it become a wafer. Okay, there is some video that we can see it later. Okay, so in order to do this, you need to be in a clean room again, and the length of the normal silicon is 200 millimeter and 300 millimeter. Okay, so let's see the flow again of the silicon wafer production. The raw material is actually the polysilicon nuggets, or it's actually from the sand. Okay, they put it inside like what we call a seed. So they pull the crystal and it becomes a silicon crystal ingot. After that, we go to the slicing. So this is what we're going to fabricate the MEMS device from this silicon wafer. So there will be additive process, substrate process, and the lithography process on top of the silicon substrate. Okay, so this is again the process. and you're going to have the mass fabrication at this wafer. So in this wafer they choose 100, and then after the fabrication process have been completed, they're going to slice to make it into dies and then packaging it. So this is what you see from all the chips. Inside the chip actually is a silicon wafer that is from the sand. Okay, so how many dies can you harvest from a wafer? So it depends on the diameter, the size of the wafer. So the larger the wafer, the more dies that we can make, and it will go to the low cost. So usually in the industry they opt for the big wafer, but for the research base, silicon wafer is quite expensive, so we usually use the 4-inch wafer. Okay, so this is again the process of the circuit board. So if you're going to integrate your MEMS device with the IC device, so inside one chip here there is a MEMS and IC device, and we're going to do dicing, and all the MEMS and IC will be packaged in one module. Okay, so is cleaning the substrate is crucial. So after you have a wafer, before you start to do any additive or subtractive process on the wafer, you need to really clean it. So this is what we showed before. So there is a dust on top when we zoom inside the scanning electron microscope, and we can see here at this figure here, batch 1 is the substrate that is not clean yet. So batch 2 is when we look inside the microscope, it has been cleaned without stains. So this is very crucial process for you to start your fabrication. You need to really clean your silicon substrate before you do any process on top. Okay, how are you going to clean the silicon wafer? Usually we use acetone. So this acetone, we dip your silicon inside the acetone and with the DI water. And how you dry it, we usually use the nitrogen. Okay, so there is some recipe for cleaning. So on top of the acetone there is another solution that is called piranha. So this is a quite dangerous solution because it have a very high concentrated sulfuric acid and the hydrogen peroxide. So usually for your quartz substrate, if you are going to go to the piezoelectric application, some of you will use a quartz substrate. So in order for you to clean this one, you need to use the piranha solutions, but you need to be very careful because this solution is very dangerous. Okay, then we go through one by one. What first is the silicon fabrication. Then you got the wafer, and then let's say you want to dope your silicon with the p-type or n-type, you need to do the ion implantation. If not, we're going to skip to the lithography, which is what we call patterning. And then after the patterning, you have some additive. Either you want to deposit your metal or other layer, and then you're going to do etch to pattern the layer. Okay, first step. This is what we call photolithography. So I will continue this in the next video. Assalamualaikum.